Hi, everyone. It's great to provide another lecture presentation with you again. It's been a while since we last worked on Mendeley referencing, which I believe is a valuable tool for your graduate writing tasks. In this presentation, I want to introduce a topic that's been gaining a lot of attention lately: generative AI, particularly large language models or LLMs. Since our course focuses on basic computer applications, it's essential that we explore emerging technologies that are becoming increasingly relevant in our academic and professional lives. Many of you are likely familiar with tools like ChatGPT and may already be using them in your daily activities. Understanding the fundamentals of these LLMs will not only help us maximize their benefits, but also make us aware of the caveats associated with generative AI applications. So, I'm looking forward to this exciting topic. Before the recent boom in generative AI, when experts referred to AI, they typically meant machine learning models that would learn from data to make predictions. These models analyze large datasets to identify patterns and generate insights without being explicitly programmed for every possible scenario. For instance, machine learning models are trained on millions of medical images to predict whether an X-ray indicates signs of a tumor. Similarly, AI models are used in finance to assess the likelihood of a borrower defaulting on a loan by analyzing credit history, income, and other factors. Other examples include models that forecast stock prices based on historical market trends, recommend personalized content in streaming platforms, or optimize supply chain operations by predicting demand fluctuations. But what do people really mean when they say generative AI? Generative AI refers to a type of machine learning model that is trained not to make predictions based on existing data, but to create new data. These systems learn patterns within training data and generate outputs that resemble the data they've seen. A glance at recent media content shows that generative AI seems to be everywhere. In fact, many of those articles and headlines might have been written by generative AI tools like OpenAI's ChatGPT. This AI powered chatbot has shown an impressive ability to produce human like text, creating everything from essays to news articles, mimicking natural human writing styles. Generative AI is not limited to text. It's also used to create images, music, videos, and more, opening up new possibilities in various industries. Since the release of ChatGPT, generative AI has captured the attention of individuals, corporations, and governments worldwide. This disruptive technology is already transforming how people learn and work. So, what does disruptive technology mean? Disruptive technology is any innovation that dramatically changes the way consumers, businesses, and industries operate. Generative AI holds the potential to empower individuals, boost productivity, and significantly contribute to global economic growth. However, there are concerns about its potential downsides, particularly regarding job displacement or other economic impacts. Given its growing influence, it's important to understand that generative AI can and cannot do, and how to effectively incorporate it into your work, studies, or business. Since generative AI is still relatively new, there is a lot of misinformation circulating. And in this lecture series, we aim to provide an accurate, non technical overview of what generative AI really is, helping you think critically about how you can best leverage this technology. This lecture is designed for everyone, regardless of technical background, and will be relevant to those in business, science, engineering, and humanities, the arts, and other fields. So let's dive in and explore this interesting topic. The base models underlying ChatGPT and similar systems work in much the same way as the Markov chain. But one big difference is that ChatGPT is far larger and more complex, with billions of parameters. And it has been trained on an enormous amount of data. In this case, much of the publicly available text on the internet. In this huge corpus of text, words and sentences appear in sequences with certain dependencies. This recurrence helps the model understand how to cut text into statistical chunks that have some predictability. It learns the patterns of these blocks of text and uses this knowledge to propose what might come next in the sequence. So, generative AI captured mainstream attention in November 2022 with the release of ChatGPT by OpenAI, and its momentum has continued steadily ever since. According to McKinsey, generative AI could contribute between 2.6 and 4.4 trillion annually to the global economy. That's in dollars. Goldman Sachs estimates that it could boost global GDP by 7% over the next decade. A study by OpenAI and the University of Pennsylvania further estimates that generative AI could impact 10% of tasks carried out by more than 80% of workers in the United States. Moreover, this study suggests that around 20% of workers could see more than half of their tasks affected by this technology. So, while all of these studies raise hopes for tremendous productivity gains, They also bring concerns about potential job loss due to automation. Generative AI systems can create high quality content, including text, images, and audio. So, one of the most well known generative AI systems is OpenAI's ChatGPT, which can follow instructions to perform tasks like generating creative outputs, for example, writing 3 captions for social media post, promoting a new line of sunglasses for robots. Many users are already familiar with consumer applications and websites that generate text in response to user input. Other notable examples include Google's Bard and Microsoft's Bing Chat. Beyond this, many companies now offer interfaces where users can input a text prompt and receive an AI generated response. So, beyond consumer applications, one of the most promising and potentially transformative uses of generative AI is as a developer tool. Generative AI can assist programmers by automating code generation, debugging, and even suggesting entire functions or algorithms based on simple descriptions. This ability to streamline software development can dramatically reduce the time and effort needed to build complex applications, making coding more accessible and efficient. By accelerating the development process, generative AI has the potential to revolutionize industries that rely heavily on software, enhancing productivity and innovation across various sectors. AI is already an integral part of our daily lives, often used without us even realizing it. So, from web searches on Google or Bing to product recommendations on Amazon or Netflix, AI powers many of the tools we interact with. It also plays a crucial role in security, such as the verification of credit card transactions. While AI systems have historically been complex and costly to develop, generative AI is changing that by simplifying the creation of AI applications. This shift is driving a surge in AI product offerings, making it more affordable and accessible for businesses to build valuable AI driven solutions. As we've discussed, generative AI can produce various types of content, including text, images, and audio. While text generation has had the biggest impact so far, image generation is also a powerful application for this technology. By providing specific instructions, referred to as prompts, AI can create stunning visuals such as the image shown here. Or it can even generate highly detailed or photo realistic images, as you can see here. Generative AI can also generate audio. There is a lot happening in generative AI right now, and it's an exciting, disruptive technology that I'm confident that you will find valuable in your work. So, in this lesson, we will explore how generative AI technology works, focusing on what it can and cannot do. You'll also see a variety of common use cases to inspire creative ways you might apply to add value to your work and life. In the later discussions, we'll delve into generative AI projects, learning how to identify useful applications and the best practices for building them. We'll also explore the range of technological options for developing impactful AI solutions. We will also explore how generative AI will affect businesses and society as a whole. We'll discuss how teams and organizations can leverage this technology effectively, while also considering AI risks and ensuring that its use is responsible and beneficial to people. I'm excited to dive into this material with you, and I hope I can provide a non technical explanation of how generative AI works. So, the ability of systems like ChatGPT and Google's Bard to generate text can seem almost magical, and they certainly represent a significant leap forward in AI technology. But how does text generation actually work? In this lecture, we'll dive into the core technology behind generative AI, and by understanding how it functions, you'll get a clearer sense of when it's appropriate to use and when it might not be the best tool for the job. So let's explore generative AI together. Let's begin by understanding where generative AI fits into the broader AI landscape. There's a lot of excitement and some hype around AI, so it's helpful to think of AI as a set of powerful tools. One of the key tools is supervised learning, which excels at labeling and categorizing data. Don't worry if you're unfamiliar with the term, we'll cover it in the next slides. Another tool is the generative AI, which has only started to work effectively in recent years. If you've studied AI, you might also recognize other tools like unsupervised learning and reinforcement learning. But for this lecture series, we'll briefly touch on supervised learning and focus primarily on generative AI. So these two, supervised learning and generative AI, are the most important AI tools today. For most business applications, mastering this will be more than sufficient for now. So before we dive into how generative AI works, let me first explain supervised learning. Since generative AI is actually built using this technique, supervised learning is a method that has made computers really effective at taking an input, let's call it A, and generating a corresponding output, which we call here B. So let's look into some applications of supervised learning that are embedded into our daily activities. Say in our email applications, have you ever wondered how your email service knows which messages are spam? With supervised learning, emails are analyzed to decide if they're spam or not. The input is an email, and the output is either zero, not spam, or one, spam. This is how spam filters work today, saving us from unnecessary email clutters. A second example is in online advertising. While it may not be the most inspiring for the common online content consumers or users, it's definitely lucrative for companies. An AI system takes an ad and some details about a user and predicts how likely you are to click on it. By showing you ads that resonate more with your interest, these online ad platforms rake in a ton of revenue. Have you ever clicked on an ad that felt like it was tailor made for you? That's supervised learning at work. What about the self driving cars? This tech is not just science fiction anymore. Supervised learning analyzes images of the road ahead and radar information to recognize other vehicles and obstacles. Imagine being in a car that can see its surroundings and navigate safely without human intervention. How cool is that? And in the healthcare field, if you've ever had an x ray, you know how crucial it is to get an accurate diagnosis. Supervised learning takes the images and suggests potential medical conditions. These applications can assist doctors in making accurate diagnosis. In the manufacturing sector, think about the devices we use every day. Have you seen how quickly products come off assembly lines? Supervised learning can inspect items like checking smartphones for scratches or defects as they roll off the line. This ensures that what you buy is up to standard. In speech recognition, the input would be a piece of audio, and that would be labeled with a text transcript. Or, for instance, in restaurant reviews, if you run a restaurant or any business, you know how important feedback is. Supervised learning can sift through reviews and classify them as positive or negative. So we call that sentiment analysis. This helps businesses keep an eye on their reputation and improve customer satisfaction. So, as you can see, supervised learning isn't just a tech term, it's actively shaping our experiences from the ads we see online to how businesses interact with their customers. I hope this gives a clearer picture of how powerful and relevant these AI technologies are in our everyday lives. So, how is learning in AI? We begin by exploring the fundamental concept of learning or model training in AI. To illustrate this, we'll use the example of creating a fork detector to understand the three main steps of AI training. Collecting data sets, that's the first step. training the algorithm, the second step, and classification. So for the first step, data collection, the first step in building an AI model, such as this fork detector, is data collection. The AI system needs a large set of diverged images containing forks. This data should capture the target object from different angles with various colors, shapes, and even conditions such as with or without food on the fork. To train the AI effectively, it requires not only a significant quantity of data, but also varied examples. In a professional scenario, an AI model for detecting forks might require more or less, or even more than 100,000 diverse examples, including the images of objects that look similar to forks, or those we call as counter examples. Next, we move on to the training process, or we call as training the algorithm or the learning process. Here, the AI algorithm analyzes each image, breaking it into pixel level details to identify patterns and features. The algorithm detects edges and shapes to recognize the fork pattern across the variations in the dataset. It uses a learning algorithm to distinguish between forks and non-forks by identifying micro differences such as shape, color, texture, material, and contrast. If the model's accuracy is low, the AI trainer may need to revisit the dataset, either increasing the amount of data or improving its quality. The process of continually feeding new data into the system, analyzing it, and testing results is called training the AI model. We also have counterexamples, like in addition to forks, the AI trainer must input counterexamples, which are images of objects that resemble forks but are not forks. These counterexamples help the AI system refine its ability to detect subtle differences and make more accurate classifications. Then for step 3, the testing and classification, once trained, the AI model is tested with new images. For example, we can provide it with a fork image and observe how confident the AI is identifying it correctly. The AI performance depends heavily on the quality and diversity of the data it was trained on. So, AI training is an iterative process of feeding data, analyzing patterns, and refining the model. If the AI performance is suboptimal, it could be due to insufficient or poor quality data that would lead to the failure of the AI training process. So, low confidence levels often indicate that the AI lacks enough examples to accurately build its model. AI systems can be highly accurate when provided with sufficient and varied data. However, without enough high quality examples, the algorithm may struggle to create an accurate model, resulting in low confidence in its predictions. So, in supervised learning, the performance of the model's output heavily relies on both the quality and quantity of the input data. High quality data, which is accurate, relevant, and representative of the problem domain, ensures that the model learns effectively and generalizes well to new, unseen instances. Conversely, poor quality data such as noisy, biased, or incomplete information can lead to inaccurate predictions and a lack of reliability in the model's performance. Additionally, having a sufficient quality of data is crucial, as larger datasets allow the model to capture complex patterns and variations, enhancing its ability to make accurate predictions, thus achieving optimal results in supervised learning requires a careful balance of both data quality and quantity. So the years 2010 to 2020 marked a significant era in the field of supervised learning, laying the groundwork for modern generative AI. During this period, we had access to vast amounts of data. However, researchers observed that simply feeding more data into smaller AI models did not yield substantial improvements in performance. For instance, in building a speech recognition system, even with tens of thousands or hundreds of thousands of hours of audio data, the accuracy gains were minimal compared to models trained on smaller data sets. This led to a pivotal realization of training very large AI models on powerful computers with extensive memory could continually enhance performance as more data are introduced. Today, large-scale supervised learning remains crucial, and concept of training very large models for labeling data has paved the way for emergence of generative AI. So let's explore how generative AI produces text using a technology called large language models, or LLMs for short. One way LLMs generate text is by responding to a prompt, which is an initial input. For example, if you input the prompt, "I love eating," which is a text, the LLM may complete the sentence with "bagels with ice cream cheese," or "my mother's meatloaf," or "out with friends." If you run the same prompt again, it might generate different continuation, like these ones that have been generated. How does a large language model, or LLM, generates text? LLMs are built using a method called supervised learning, which involves inputting data A and predicting an output we call B. In the case of LLMs, supervised learning is used, and the goal is to repeatedly predict the next word in a sequence. For example, if the AI system has seen the sentence, "My favorite food is a bagel with cream cheese" on the internet, it breaks that sentence down into several learning examples. One data point could be given the phrase, "My favorite food is A," What is the next word? In this case, the correct answer would be bagel. Another data point could be given my favorite food is a bagel. What is the next word? The answer here is with, and so on, as you see in our examples. So this process creates multiple input-output pairs from a single sentence, allowing the LLM to learn how to predict the next word based on context. When you train an AI system on massive amount of text data, hundreds of billions or even trillions of words, it becomes highly proficient at generating coherent responses to prompts. This is how systems like ChatGPT work. They generate relevant text by predicting what comes next based on the input. So while I'm skipping some technical details for now, we'll dive deeper into how LLMs not only predict words but also learn to follow instructions and generate safe responses in our next sessions. At its core, though the technology behind the LLMs is all about learning from vast amounts of data to predict the next word in a sequence. Many people, perhaps including including us, are already finding these models helpful for our daily tasks, whether it's writing assistance, finding basic information, or even helping you with brainstorming and thinking through ideas. So there are several web interfaces that allow you to access large language models or LLMs. ChatGPT is the most well known, but others like Google's Bard, Microsoft, Bing, and more also perform effectively. So let's explore how people are using these LLM applications, whether you're already using them regularly or not. I hope this gives us some new ideas on when and how they might be useful to us. So LLMs provide a new way to provide information. For example, if you ask for the capital of the Philippines, it will likely give the correct answer. However, as we'll see later, LLMs can sometimes make up facts, which is known as hallucination. So if you need to rely on the accuracy of the information, it's a good idea to always double check the answer with an authoritative source before fully trusting it. In some cases, the LLM get facts right, like the capital of the Philippines. Additionally, a back and forth conversation with an LLM can help refine the answer. So for example, if you ask what LLM stands for, it might respond with Legum Magister, a common use of the acronym in law. But if you follow up with what about in the context of AI, the LLM should correctly explain that it refers to a large language model in that context. This type of interaction can help the LLM provide the information you're looking for more accurately. LLMs can also serve as thought partners to help you work through ideas. For instance, I often use an LLM to refine my writing. If you ask it to rewrite a paragraph or sentence for clarity, the leading LLMs can effectively improve the text. Here's a fun example. If you were to ask, if you were to ask it to, let's say, write a 300-word bedtime story about a dinosaur, perhaps because your child loves dinosaurs, as my son does, you might request a story that encourages the LLM to encourages our children to brush their teeth. So the leading LLMs can create entertaining and engaging stories for this purpose. Well, I do think these stories can compare to those written by great novelists. They can be fun and a quick option for a light-hearted tale. Sometimes you might wonder whether to use a web search or an LLM when looking for information. For example, if you're playing a sport and you sprain your ankle, you'll want to know how to treat it. A web search can help you find reliable sources with trustworthy advice, like websites from the Mayo Clinic or Harvard Health. These sources are well known for providing accurate medical information. You could also ask an LLM for advice on treating sprained ankle, and it will give you an answer. However, LLMs can sometimes make up information and present it confidently, which can be misleading. Because of this, it's a good idea to double check any health or medical advice from an LLM with a reputable source before following it. Here's another example. If you want to make, let's say, a pineapple pie and need a recipe, you'll find plenty of options on the internet. Choosing a recipe from a trusted website or a reputable chef is likely to give you good results. But you could also ask an LLM for a pineapple pie recipe, and it might come up with something decent. However, there's a good chance the recipe could be a bit unusual or not very reliable. So if you're looking to bake a pineapple pie, I recommend searching for a recipe on a well-known website. You'll find many solid options that will help you make a delicious pie. But if you're looking for, let's say, something more unique, like if your friend challenges you to make a coffee infused pineapple pie, you might struggle to find good recipes online. In fact, I don't think there's a single web page that provides a solid answer for that specific request. This is where an LLM can be helpful as a thought partner. It can help you brainstorm ideas for how to create a coffee infused pineapple pie. These are just few tasks where using an LLM can be beneficial. We'll explore more examples, discuss the strengths and weaknesses of LLMs, and go over some best practices. As you can see from the examples, generative AI can do many different things. In the next slides, we'll take a closer look at generative AI as a general purpose technology and start organizing the various tasks it can handle, including writing, reading, and chatting. So, what is generative AI good for? This question can be a bit tricky to answer because AI is a general purpose technology. Unlike technologies like cars, which are specifically for transportation, or let's say microwave ovens, which are designed for heating food, AI can be used for many different things. This variety makes it harder to pinpoint its specific uses. So let's break down what a general purpose technology means. Similar to electricity, which serves many functions, AI can also be applied to various tasks. If we ask you what is electricity good for, you might find it hard to list everything simply because electricity is everywhere and powers so many things. For example, supervised learning, a key part of AI, is useful for tasks like spam filtering, advertising, speech recognition, and much more. Generative AI is similar in this regard. In the previous slides, you saw some tasks that a large language model, LLM, can perform, such as answering questions and helping with writing. Now, let's discuss a broader framework for understanding tasks LLMs can do. First, let's talk about what generative AI is good for. One of its main uses is generative text. So it's great for writing tasks. For example, I often use generative AI as a brainstorming partner. If you're writing to name a product, you can ask it to suggest ideas and it will come up with creative options. Generative AI also help answer questions. If it's connected to specific information about a company, it can help employees find details they need, like whether parking is available at an office. In addition to writing, generative AI is helpful for reading tasks. It means giving it a long piece of information and having it summarize or give a simple answer. For example, if you run an online store and receive lots of customer emails, generative AI can quickly figure out if an email is a complaint or not. It might identify positive feedback like, I love my new Llama t-shirt as not a complaint. But if someone says, I wore my Llama t-shirt to a wedding and my friends got mad at me for stealing the show, it might flag that as a potential complaint. So this helps route emails to the right department for quick handling. We call this reading task because the AI processes a long email and generates a short answer like just a yes or no about whether it's a complaint. While traditional AI, supervised learning, can also handle this, generative AI allows this task to be done more efficiently at a lower cost. Lastly, generative AI is often used in chatbot applications. Tools like ChatGPT, Bard, and Bing Chat are general purpose chatbots, but generative AI also enables special purpose chatbots like one that can take online orders. For example, a chatbot could take an order when a customer types, I'd like a cheeseburger for delivery, and the chatbot processes the order. When discussing this task, it's helpful to distinguish between the two types of LLM-based applications. First, the web interface-based applications, like when you use a large language model through let's say ChatGPT or Bard, to get quick results by typing in a prompt. The second type is LLM based software applications, which are built into larger systems. For example, recognizing complaint emails would be part of a company's email routing system, not something you'd go by copying and pasting emails into a chatbot. These applications are integrated into software to automate tasks like managing emails or answering company specific questions, such as parking policies. A general LLM on the internet wouldn't have that specific information. In our later discussions, we'll try to explore how these specialized chatbots and software based LLM applications are built. So, throughout the rest of this lecture, we'll use two symbols to differentiate between web interface use cases and software based LLM applications. For many people, starting with web interface use cases is often easier because you can simply visit a website like ChatGPT, Bard, or Bing, type in a prompt, and receive a response right away. However, both web interface applications and software based LLM applications are important and can be very beneficial for individuals and businesses alike. Organizing tasks into three categories: writing, reading, and chatting is a helpful way to understand the various things a large language model or LLM can do. In our upcoming discussions, we'll explore many examples of writing, reading, and chatting tasks in more detail. Thank you.